In the previous video I showed the assembly of this device. It came as a kit. I purchased it off eBay for £20 delivered, and it is of course an oscilloscope. So nice small handheld oscilloscope, £20 all in. That includes all the parts, and the question really is it worth paying £20 for? Now, I did receive a comment after the previous video saying that I should have gone for the newer version. Well, the newer version costs about twice as much, so it wouldn't really be a £20 handheld scope if I'd gone for the newer version. And in all honesty, once you start getting to more than £20 for one of these, you may well be better off going for a good second-hand scope rather than one of these. So the question really is this even worth £20, and should you get one? And the real question, I suppose, is going to be dependent on how it performs. Now, in terms of building it, it was relatively straightforward. The instructions aren't particularly clear. They're adequate. The main problem with them is they're for a different version of this that seems to have more through-hole components. It doesn't really matter because where it's showing through-hole components on the instruction, they've been changed to surface mount and they're already fitted. So any components on here that it shows that aren't in the kit are already fitted to the board. So nothing's missing, it's just that there are fewer parts to fit than the instructions would tend to imply. So we'll have a quick look at the specification. It claims a sample rate of 1 megasamples per second. Bandwidth for the analog is 0 to 200 kilohertz, so DC up to 200 kilohertz. Sensitivity is claimed to be 5 millivolts to 20 volts per division. Maximum input is 50 volts with a ×1 probe. And input impedance 1 meg at 20 pf. Claimed 12 bits resolution, which is actually quite good. And it has a record length of 1024 points. Time base range is 500 seconds a division to 10 microseconds a division, so it's certainly not a speed machine. Trigger modes are auto, normal and single shot. The trigger is fixed at the center of the buffer though, the record buffer, so you can't move it around and examine the data that you captured, although you can store a waveform. Power requirement is 9 volts at around 120 milliamps. This unit draws just on 100 milliamps, so if you did want to power it from a small internal battery it would work, but it wouldn't last very long. And the weight's about 100 grams. It's got quite a nice feel to it. It's not it doesn't feel like an expensive device. It is cheap plastic, but it's definitely adequate for what it is. It's got a bit of weight to it, so it's quite nice. All the buttons work as they should. They pass through the case properly. Everything fits the way it should. But it does still feel a bit cheap. I think the main thing is, although it's got quite a nice encoder with a clicker on it, and it does feel quite nice, I think the knob they used spoils it. It does feel very cheap. If they put a bigger knob on here and spent a few pence more on that, it would make a big difference. Other than that, it's good. Everything fits. They went together reasonably well, and so the real question is it worth £20? And to answer that, we need to look at its performance. But I think there are two parts to that question. One is it any good as a scope? And the other is it any good for something else? So we'll address the first one to start with. Is it any good as an oscilloscope? So what I intend to do is run some very basic tests on this. I'm not going to do a full parametric test on it. I'm just going to see how it performs, how easy it is to use, and try and get some idea for if it's got any uses in the lab or in the field for testing. So the setup I have here is very simple. We've got a signal generator feeding the signal out to a BNC T-piece. One cable goes off to the lab scope and the other cable goes off, and we'll plug that into our handheld scope. Now I'm not trying to compare these two scopes, I'm not trying to compare this one with this one. I just have this hooked up so we can be sure that if we see any artifacts on this scope, then we know that they are not coming from the signal generator. Okay, so next step is we'll get it powered up. As I say, although you could power it from a battery, I've got it hooked up to the lab supply, so I'll turn it on. So very nice, very bright and clear display, good high resolution, nice bright colourful. In terms of viewing angle, it's good in all directions. We can probably go up to about 30 degrees easily in any direction and it's still viewable. If there is any flickering on the camera, it's certainly not evident in real life. It's a very nice clear display. The only part that does flicker is the trigger indicator. It seems to refresh each time a new sweep is started. It's not particularly annoying, but it would be nice if they could stop it doing that. In terms of the indications and the use, it's all very intuitive, very straightforward. The selection that is being adjusted, it has either a blue border around it or is selected in blue. So if we want to adjust the sensitivity, we just make sure it's selected, and then we can change it with the knob. If we want to select a different parameter, for example the time base, we just press the time base button. We've now got the speed of the time base highlighted, and we can adjust that. Same with the trigger. If you want to adjust the position of the trace on the screen, then you just click the same button again, and notice that what's happening here, I don't know if you can see this on camera, is the small indicator to the left of the center point changes to blue to indicate that we've selected it, and we can now move the position of the trace up and down. It goes quite slowly. There's no speed control over this, but if you want to speed up the rate at which it's moving or adjusting anything, then what you do is you press and hold the knob and you'll get a symbol appearing at the top of the screen, and that's indicating that we're now in a high speed mode, and now it will move or adjust whatever you've selected much more quickly. And then of course you can go back to normal speed by hitting the button again, and then you're back to fine adjustment. Okay, so it's as easy as that. If you want to center anything or call up any parameters on screen, what you can do is press and hold the OK button, and you'll get quite a nice selection of parameters showing on the screen. Quite useful: frequencies, cycle, duty, Vmax, Vmin, average, peak to peak, RMS, that sort of thing. Quite nice. And if you hold the button again, that will disappear. It doesn't refresh the screen automatically when you do that. You need to get it to do a scan, but you can do that by just hitting the button once and it will start up the scanning again. Okay, same with trigger. If you hold the trigger in, then what that does is it centers the trigger point and allows you to select whether you're looking at rising or falling edge trigger. So with all the buttons, holding them in will select a different function. You can then use the knob to adjust the function, and then when you're happy, just press the button again and it will change the selection. Okay, so that's it for the controls, all very straightforward, and what we'll do now is see how it performs with the signal going into it. So we'll start with a square wave. It's set to 1 kilohertz, 2 volts peak to peak, so I'll turn the output of that on. We'll start the scope up. On the lab scope we're seeing exactly 2 volts peak to peak, and on the handheld again exactly 2 divisions, and I've got it set to 1 volt per division, so it's looking quite promising so far. If we want to adjust it, we can go up to double the sensitivity, and now it is showing 4 divisions, which again is correct. As I said, if you want to move the position, just click the button once and then we can set the position wherever we want. Click it again and it selects the amplitude again. If we want to pull up the parameters on screen, we'll see if they match. So we've got this set to 1 kilohertz. This is showing 1.001 kilohertz, 998 milliseconds cycle time. So you can see it's actually fairly precise. We've got 50% duty cycle set on the generator and it's showing 48 on the scope. Vmax 1.01 volt, Vmin minus 1.13, so it's a little bit out there but not too bad. You can zero the center point. There is a ground position on the selector switch at the top, and that allows you to zero out the center point for the readings. So if you wanted to do that with no signal going in, then that in theory at least should or null out this offset. Okay, if we want to center the display, then we press and hold the horizontal position button for 3 seconds. If we want to center the trigger, we press and hold the trigger button for 3 seconds. You can then adjust the trigger to whatever position you want, and the same thing with the vertical position. You press and hold, and then that will automatically zero the center position, but you can then, if you want, adjust it. So I'll now turn the signal back on, and we can see that this has nulled out the Vmax and Vmin. They're now both reading what they should, so one's reading 1.05 volts and one's reading minus 1.05. Okay, so you do have quite nice control over the display, and it is useful for looking at these low speed signals, but at the moment we're only looking at a 1 kilohertz signal. So I'll get rid of the readings on screen, and we'll now start to increase the speed of the signal we're feeding in and see how well the scope copes with it. It's meant to be a 200 kilohertz analog bandwidth scope, so let's see if that's actually true. I'll change to a sine wave. Obviously a square wave is not going to go up to 200 kilohertz. Okay, so we'll start to increase the frequency. I'll go to 5 kilohertz. And we'll try a few different. Okay, so it has some really bad aliasing, so you will need to be fairly sure what frequency you're feeding into this before you can be certain that what you're looking at is what you're expecting. So that's certainly aliasing. It thinks it's a very low frequency signal, so as I say, you do need to have some idea what you're feeding into it, otherwise you could end up getting very confused by what's on the display. Okay, we'll go up to 10 kilohertz. So amplitude is still 4 divisions, which is fine. Trigger's a bit jittery, but not too bad. It's certainly viewable. And we'll go up to 50 kilohertz. So more jitter still. So obviously single shots it works fine, but in auto and normal it does jitter quite a bit. Okay, we'll go up to 100 kilohertz, and the amplitude is now starting to drop. So just as a general rule of thumb, if the bandwidth is as it's claimed to be, then we should get to about 3 divisions peak to peak by the time we reach the claimed bandwidth. And we'll go up to, when I go up in 10 kilohertz steps, so that's 100 kilohertz. 110. Okay, it's actually doing quite well. We're at 140 kilohertz, but we are now starting to get some artifacting on the display. We're starting to lose the form of the signal, so I suspect the 1 meg sample rate is maybe a bit optimistic. It does not appear to have the full 1 megasample rate, or the processing of the signal is very simplistic, which could well explain it. What we're getting is a jitter and variation in the amplitude of the signal from cycle to cycle. I can't increase the time base any further, it's already at its maximum rate, but what we're seeing is some of the peaks of the signal are being truncated, so it looks like it doesn't have the sample rate to properly sample the signal, and because it's not oversampling, then it's just a direct sample display system. Okay, so we'll keep going up. Okay, the amplitude is now starting to drop. I'd say at this point it's pretty much unusable for this. You couldn't really use this to take any sensible measurements. What I will try doing is bringing up the measurements on screen, see if it can actually deal with this frequency. Okay, it's actually not too bad. It's showing it as 162 kilohertz. The Vmax and Vmin is about 0.9 volts and minus 0.9 volts respectively, and voltage peak to peak 1.8. So it's actually not too bad in terms of it being able to analyze the signal that's been fed into it. It's not displaying it very well, but it does seem to be able to measure it. Okay, we'll keep going up to the claimed 200 kilohertz and see what we get. So that's 200 kilohertz. The display is now unusable. It does not incidentally claim that you can use it to 200 kilohertz. It just says that the analog bandwidth is 200 kilohertz. And that's one of the things you do need to be careful of with specifications for equipment like this. But as you can see, the signal we're feeding in is fine. That's not where the problem lies. The problem is definitely with the sample rate of the handheld. Again, we'll just check the measurements and see if they are correct. So it's saying 203 kilohertz. It's not too bad. It is actually giving the expected Vmax and Vmin. So it's giving us about our 3 dB reduction in signal levels. So it is in theory meeting its specification. The fact it can't display it because the sample rate's not high enough is perhaps a different issue, but certainly it is usable as a signal measurement and analysis tool, as long as you weren't interested in absolute accuracy. Out of interest, we'll see how high it can go before it loses the ability to measure the frequency. So I'll continue increasing the signal rate. So we're at 250 kilohertz. It is still measuring that. So it's saying 252, so it's overreading slightly, but it's been doing that all the way up. I'll keep going up. And now it's no longer working, it's saying 220. So 250 kilohertz seems to be its absolute limit. Above that it can't measure the signal, but at 200 it can measure it. It can't display it very well, but it can measure that. So we'll go back down to 100 kilohertz and I will try feeding in a square wave and see how that looks on the screen. And it looks like a sine wave with some distortions. So this is to be expected. Square waves obviously need much higher bandwidth to display properly, and 200 kilohertz bandwidth front end is not going to allow a 100 kilohertz square wave. But out of interest, we'll see what the maximum reasonable square wave rate is that it can handle. So we'll start going down. It's 90, 80, 70, it's starting to look like a square wave, 60, 50, So if you were trying to figure out what you're looking at here, you could probably arguably say it looks like a square wave. So 30 kilohertz. So I mean, really I would say that's probably your limit as far as frequency is concerned for a square wave. 20 or 30 kilohertz, above that and I think it's really struggling to show it. Arguably you could perhaps say 50 kilohertz. It depends on what you're trying to do. It's certainly in terms of being usable just for some very basic and simple signal observations, then it's fine. Whether it's worth it as a scope depends on exactly what you want to use it for. For a lab scope, no, it's no good. But for just some general testing in place of a multimeter or something else, or if you want to use it to measure signal frequency up to a couple hundred kilohertz, it's actually quite good. It's certainly reasonable. So really that brings us on to the second part of the value for money and is it worth it question. So in terms of value for money, the first question, would I recommend buying one of these for use as a lab scope? And the short answer is no, I wouldn't. It doesn't have the bandwidth and it doesn't really give you the versatility that you'd be looking for in a half decent or even low-end lab scope. However, if what you wanted it for was the fun of making up a kit and having something that does have its uses, you can use it if you need something that is field-based, or if you need something that is floating. It's not going to cause any issues if you want to monitor something that needs an isolated scope, then certainly these are quite useful. I wouldn't use it on the mains, it's not in any way safe to use on the mains, but certainly in terms of an isolated scope it has its uses. It would be useful as a signal monitor. You could use it for low frequency measurements in terms of amplitude and frequency, as long as you weren't that concerned with accuracy. But I think where its value really lies is if you want to develop your own applications, if you want to make your own product or try some things out and experiment. I think this would be an ideal basis for that. There's a nice case you've got to put your board into. It would be very easy. It's got an ARM Cortex processor on the board. It would be very easy to just put a link in there so you could flash upgrade the onboard processor. Once you've drawn out the schematic and got all the information you need for how to interface to this, it would be an ideal tool to use for developing your own projects. And I think that's where its real value lies, and it does even kind of hint at that in the listing on eBay that I saw, in that although it comes as a scope, it's meant to be used as a scope in the kit, I think its real value is maybe to use as the basis for experimentation and see if you can use it to make maybe a nice graphical multimeter. It's got an analog front end that's quite capable of decent measurements, 12-bit resolution measurements, so that will give you quite a good front end for a multimeter. Again, it's not going to give you a Cat 2 or 3 meter, but certainly if you want something to experiment with, data loggers, anything like that at all, then it would be an extremely good platform for doing that. So for £20 I think it would be worth it as a development tool. You can get development boards for less than that, of course, but this has got a case, display, keys, encoder, a decent connector, some switches you could make use of for your code, and it's got quite a decent powerful processor. So I think that's the only thing I could recommend it as being useful for in the lab. I personally wouldn't use it as a scope. Maybe very rarely, if I just needed to take this down to the workshop and do some very basic measurements, it would be useful for that. It does come with its own lead, so a couple of crocodile clips and it would be useful for taking some rough and ready measurements. If you suspect you've got a problem with a power supply or something like that, then it will be quite useful. But its uses are limited, but then it costs £20, so I can't really complain at that. So overall, if I wanted something to use as a platform for development, I think it's worth paying £20 for. As a learning tool, I think it's worth paying for. Any more than that, then I don't think it would be worth it. It needs to be £20 or less to be worth purchasing. So in short, if you want something to experiment with, to build, see how it works, and to use as the basis for your own projects, then I think it's worth paying the £20 for. If you want a scope for your workshop or your lab, then I would recommend getting a decent second-hand scope instead. Don't invest in one of these as a lab scope. It just won't be used. You'd end up putting it on a bench after the first week and never using it again. So that's it for this video. Any comments are welcome, but bear in mind this video was about this particular unit. There are many others you could look at. I may have a look at the second version of this, but as I say, I can't really recommend a scope like this if it costs more than £20.